Okay, hello everyone. So today I'm going to film myself making an anchor chart for our geometric transformations. So these are the 4 transformations that we're going to be working with. We have a rotation, reflection, translation, and dilation. So we're going to start off with a rotation. So if we remember what rotate means, the word rotate is in the definition. So a rotation, a geometric rotation, is when you rotate a figure about a certain point. Point by a certain degree measure. So one thing to note with rotations too is when you rotate something, you always rotate it in the counterclockwise direction. So let's make sure we note that. It's always counterclockwise unless other stated. So what does this look like? Let's draw a picture. So if I start with my triangle, ABC, and I rotate my triangle 180 degrees counterclockwise about point C, what I can do is mark that degree measurement. So if I take point B to point C, and then I can measure 180 degrees. So point C is what I'm rotating about, so I don't have to move C, but point B gets rotated 180 degrees, and this becomes B prime then. And then point A is also getting rotated 180 degrees. So this is now going to be A prime. So then my new triangle is going to be A prime, B prime, and C prime. So rotations is one of them. My next geometric transformation is a reflection. So if you're standing in front of a mirror, most likely you'll see your reflection in front of the mirror. So this is about the same thing. So our geometric reflection occurs when you flip a figure and all of its points about a line of symmetry. Now most of the lines of symmetry that we're used to is just our x and y axis, but a line of symmetry can also be some kind of function, like some kind of linear function. We can reflect a shape about the line y equals x. It really depends on what the question asks us. So let's draw an example. So I'm just going to make a coordinate plane, x and y axis, just because that's what I'm feeling right now. And I'm going to draw a triangle in the 4th quadrant. We're going to name this one EFG. And if I reflect this triangle about my x-axis, it's just going to be what it looks like. So that G is still going to be that many units away. Except now my triangle is going to look upside down and be in quadrant 1. So now my reflected triangle is triangle E prime, F prime, G prime. Our next geometric transformation is our friend, a translation. So a translation is like, if you've ever played the game Tetris, you're literally just moving this shape to the left or to the right or some kind of vector movement. So when we translate a shape, it occurs when you move every single point or every single vertice of your figure by the same distance either vertically or horizontally. Or in a vector movement. So let's draw our coordinate plane again. This time I have, let's do triangle RST. If I translate to the right 2, so right 2, down 3, then I'm moving all of those points in that direction. So right 1, 2, 1, 2, 3, that's my new R prime. 1, 2, 1, 2, 3, that's my new T prime. 1, 2, 1, 2, 3, S prime. So now I have R prime, S prime, T prime. And then our final transformation that we're going to look at in this unit is dilations. Now, if you watched Miss Eilerman's video before mine, you probably already know that a dilation is when you multiply a certain figure by the same scale on all of your sides. So one thing I want to mention about dilations and how they differ from rotations, reflections, and translations is that rotations, reflections, and translations are what we call rigid transformations. That means that the side lengths are preserved, the angle measurements are preserved. For dilations, since we're multiplying by either a scale factor greater than or less than 1, the size of my shape is going to differ, but the angle measurements are still going to be preserved. So a dilation is when you multiply each of the sides of a figure by the same scale. So if we multiply by something that is greater than 1, our shape is going to get larger. If we multiply by something that is less than 1, our shape is going to get smaller. So let's do an example. So let's say this is my original, we're going to go with a square this time. So let's say I have square ABCD, and I multiply each of these side lengths by a scale factor of 2. Then that means that each of my side lengths are going to be twice as long. So I'm going to get this type of figure. And then I have A prime, B prime, C prime, and D prime. But notice that since I'm working with a square, all of my side lengths are still the same. It might not look like it, but this is my goal of having a square. And all of my angle measurements are preserved. Now my side lengths are multiplied by a scale factor of 2, but for a square, you know you have to have all congruent sides. So yeah, those are our 4 geometric transformations, and I will move the camera a little bit closer so you can kind of see what we're working with. If you want to take a screenshot, it might be helpful for the activities for the day. Thanks for watching.